first of all, welcome everybody. This is one of the Friends of the Planetarium weekends, and what we do at the Friends of the Planetarium, we're kind of the fan club for the planetarium. So what we do is co-opt the regular APS scheduling one weekend a month, kind of create a theme, something we think is going to be interesting, at least to us. And then we cobble together a program. Now, to say that we've got these two guys and a program we've cobbled together is kind of understating sort of the importance of these two guys. So really, no elbowing me for that comment. But what we have this weekend was sort of a dual theme. You escaped the love at the planetarium thing. That was a couple nights ago. We did Valentine's Day date night at the planetarium, and then we switched topics today to climate versus weather. Now, during the months of preparation for this talk, little did we know that we would have all kinds of climatological, meteorological events that would come up, so that would sort of inform the talk that we're going to have today. But this is sort of a climate versus weather, what's the difference? That's sort of the theme here. Now, a lot of you maybe have come in already with some ideas of what you think the differences are. So we've got two professionals from the local area and really kind of nationwide to help us out with this. So I'm going to start, I think what the slides say, if you cue the first one for us, Ron, we're going to be upside down. We're going to start with Jason Samenow. Jason is the chief meteorologist for the Capital Weather Gang, as well as the weather editor for the Washington Post. And if you glance up there, you can see the first bullet. I really had no idea that in high school, Jason interned for Bob. Who knew? So these guys kind of have a history of talking weather and climate and meteorology here in the local area. And I put Jason's academic credentials up there as well, the very, very minor bullet points. There's probably much more I couldn't fit. So that's who we're going to hear from today, as well as, if you go to the next slide, Bob Ryan. Now, I think everybody in this room probably knows who Bob Ryan is. But again, doing a little bit of bio data checking here, we put up the degree stuff there. I had no idea, this is simplifying things a little bit, but I had no idea that you and Willard Scott basically changed jobs.
Right.
Again, that's probably a little bit more detail there. But Bob was the first national meteorologist on the Today Show. And then he and Willard changed spots. Willard was doing the weather here in DC. They swapped, and then 30 years later.
And the picture is from?
Yeah, the picture that you see there is from the grand reopening of the planetarium. So that picture was taken here in the dome. Bob came out, did a live shot from the planetarium, and I was getting pinged on social media saying, "Oh my gosh, Bob Ryan's at the planetarium." So it was wonderful. So here we have it. Was there anything else here?
No.
Oh my gosh, recently retired. So we're
Oh, yeah.
really thankful to have him kind of come out of retirement and do this for us. So I think without any further ado, I'm going to turn it over to these guys and stop talking. But I really want to thank you all for coming very much. And if you would just say next when you're ready for the next slide. Next. I guess I'm supposed to ask the question here, though. What do you guys think?
Anybody know who these people are and what they are standing in front of? This was about 50 years ago, and it was the group that conducted the first experiment on numerical weather forecasting using the basic equations of science and physics and a computer which is behind them. The computer is ENIAC. ENIAC, and that was the first group about 50 years ago. Imagine, no weather satellites, limited radar, really no radar, and no computer simulations of the weather or the climate. Now, it's interesting, there's a site, if you want to, you can go and you can get what their initial efforts were, and you can put it into your iPhone now and run the same simulation, the basic simulation that they ran on ENIAC back in the mid-50s or so. And I had the, now that I'm retired, had the great honor of meeting 3 of those people and chatting. Okay, next. Anyhow, that gives you a little perspective, as this does. This is a bit where we are now, where we live, of course. This is the some of the satellite imagery from the latest and called the Sumi polar orbiting satellite. These are actual pictures now, composite. Next. So there we are in North America, and that gives you an idea of what's possible. The next. And I put this together because this is a picture from the space shuttle when they were doing the Hubble, and you can see the Earth. Can you see the atmosphere? Next.
Yes.
There it is. So another picture. The next is also, this was a recent one from a Japanese astronaut who's up there. A great picture showing the Earth's disk and the atmosphere and the crescent moon. Next. And here's a picture. I think this is probably maybe from a YouTube, but I'm not sure. But it gives a perspective. You can see a thunderstorm there. So what are the relative dimensions of what we're talking about when we talk about next? The Earth diameter, 8,000 miles. And there you can see the atmosphere again. Next. It's about 10 miles thick. So it's a pretty fragile little shell that we live in here. Next. And so when we're talking about weather and climate and which is which, the two, as Jason will talk about, are really intertwined. You can't separate one from the other to a large extent. Next. So here's, I think maybe, try the next one. So this is I'm not above still stealing really good stuff. So this is from Stu Ostro, and next, the way to think about it in the perspective is climate is the book, weather are chapters, and next, and you know, when he's talking about climate and climate change, he uses this analogy, and I think it really is neat that the bubbles are the individual weather events that are going on, and gradually as we're going through climate change, it's sort of thinking about that great shell or that great pot around us. Next. So, and the idea that the climate may be variable or changing is not any recent new idea. This was from the early hundreds BC. There's the quote from, and that's a great book on the perspectives if you're on climate change by Jim Fleming. Next. And this is toward the end. So the question is the climate changing? Well, there's a record going back millions of years using these proxy ice core measurements, various things, and we can see that there are a number of drivers, certainly of the climate, the variability of the solar output, the variability of the orbit, the inclination of the orbit. So sure, the climate has changed, is constantly changing. It's not a static thing. Next. And the one thing that is changing, of course, is the chemistry. There's the amount of carbon that's been released in the last couple hundred years or so. So it's, and it was up to 2010, but the trend is not changing in the various parts. And what's interesting is that we sort of focus on what impact does it have on weather or climate or the atmosphere, but most of the carbon is going into the oceans, which are absorbing. So when we think about climate, we have to include everything from the microscale climate of our room, which will, if we close the door, heat up to 98.6 within a couple of hours, and the local climate, but everything from the lakes, from the land, from the streams, and certainly from the oceans. Next. And I was just back from a trip, wonderful trip around South America, including the Chilean glaciers, and this was Alma Glacier, I'm not sure. But what was interesting is that if you've ever been to Glacier Bay in Alaska, it's very noisy. You can hear the glaciers are advancing fairly fast, and it's pretty exciting. It was quiet. This is a dying glacier. It's receded tens of miles over the last just 20 years or so. And Chile is very concerned next on the loss of glaciers and the receding glaciers, the alpine glaciers in the Andes, because that's their source of water throughout the whole country. Next. So here's the last one, and I happened to be, just before we came back, this was a newspaper article on the documentation of the recession of the glaciers in Tierra del Fuego. And so it's a big story down there. And through many parts of the world, it's a science issue, but it's a great concern because in going forward, I think the one thing that we have to all think about is what impact does, whether you ascribe it to natural variation or our human footprint, what is the impact on water resources? That will be probably more valuable in younger lifetimes than gasoline, perhaps. So I'll just finish up there with that overview. I think the next slides are Jason's.
Great. So just to talk about climate and weather a little bit more before we talk about the meat of my slides, Bob mentioned a couple of good metaphors for thinking about climate and weather, but a couple of sayings which might help you understand the difference. And this one goes back a while. I think Mark Twain may have come up with it or someone, but it's climate is what you expect, weather is what you get. Another one that I've heard from Marshall Shepard, who's the past president of the American Meteorological Society, he says, climate's your personality, weather's your mood. So that's another way. It's another good way of thinking about it. So speaking of weather, I'm just going to talk about the weather here in D.C. in the last 5 years or so, and try to put it into a climate context and talk about some of the prevailing themes. And if we look at the last 5 years in D.C., basically 20 to 2013, and maybe not so much into 2014, but the theme has been a lot of warmth, a lot of exceptional warmth, a lot of heat. Although, as I said, January and February have actually been cooler than normal, but we'll put that in perspective in a moment. But if we look at 2010 to 2013, it's an incredible laundry list of warm weather milestones that we've set in the DC area, and I'll just talk about them briefly. We had our 2 warmest springs, 2 of our 4 hottest Junes, our 2 hottest June days, our 3 hottest Julys, 2011, 2010, 2011, 2012. 3 hottest summers on record, back to back to back, 2010, 2011, 2012. Earliest 100-degree reading in a day, longest stretch of temperatures above 80. That was last summer, which was just a little bit warmer than average. It was actually a pretty nice summer, but we did have a pretty miserable stretch there in July where it was just, we had several consecutive nights where the temperature stayed above 80 degrees in the city. We had our most 100-degree days in a month, 7, that was July 2012. We had our tie for our most consecutive days at 104 in that same July 2012. We had in 2010, we had 67 days when it was 90 or higher, which tied for the most on record in DC. We had our most 95-degree days in a year, that was 2012. And we had at least 50 days at 90 or higher for 3 straight summers. So it just goes on, and even into the fall, we had our second longest freeze-free period, our earliest last freeze, our third latest first freeze, and 2012 we also had our 3rd warmest winter, and 2012 as a whole was the warmest on record in DC. So just a phenomenal slate of warm weather records when you think about it over a relatively short period of time. And we can think about there are potential reasons for that. The region's been urbanizing, there's an urban heat island effect, but of course, as Bob alluded to, the CO2 concentrations in the atmosphere have been building, and they've increased 40% since the Industrial Revolution. So we have these very local scale climate changes when we think about urbanization and the urban heat island effect, and then we have these larger global scale changes in the composition of the atmospheric chemistry, and the increasing concentrations of greenhouse gases from not only carbon dioxide, but methane, nitrous oxide, fluorinated compounds like chlorofluorocarbons and hydrofluorocarbons. And so there's all sorts of stuff we're putting into the atmosphere which basically traps heat. And we're seeing that play out on a global scale, and probably on the local scale as well, although it's harder to isolate, it's harder to say on a local scale that global changes in atmospheric composition are having are the cause of any particular heat wave or stretch of warm weather. But if we go to the next slide, we should just think about how the distribution of our temperatures has been shifting. So in a climate which is static, you would expect to have roughly an equal amount of record cold weather and an equal amount of record warm weather. But when in a warming climate, what you're going to see happen is you're going to see more record heat and less record cold. So we're seeing our whole distribution of temperature shift. And we're seeing that play out, as I said, not only at the global scale, but also at the local scale. And if we go to the next slide, it becomes really apparent when we look at Reagan National Airport and we look at the ratio of record highs to record lows over time. Now this goes back to last spring, through last May of 2013, but in the since 2010, we've set 62 record highs and only 4 record lows. And again, there's an urbanization signal there, and there's also probably a global climate signal there. We go to the next slide. We look at winter temperatures, and we can see that winter temperatures are warming markedly in every month. The average temperature since the late 1800s in the winter in DC is up about 4 degrees. Now, to be a little bit careful here because the observing station in DC has shifted, whereas prior to 1945, the observing station was actually downtown. It was at 24th and M Street, which is in the Foggy Bottom area, and now it's at Reagan National. And the climates there are marginally different. I don't think the shift in observation station is responsible for the trend. I think maybe National Airport's a slightly warmer location than that more downtown location, because National Airport's right on the river, so you get some moderating effects from the river there, and it's also at a very low elevation. So there might be something going on there in terms of biasing the temperatures a little bit warm, but still, I mean, when you look at a 4-degree increase over 100 years, or a little bit more than 100 years, that's a notable change. Next slide. Let's talk about snow a little bit. And for snow lovers around DC, this is sort of a depressing graphic because, gosh, I mean, in the late 1800s, DC was averaging about 22 inches of snow a year. Now our 30-year average is about 15 inches. And the thing about that 30-year average is that 15-inch average takes into account some of our really big epic winters when we had Snowmageddon, we had the blizzard of '96, we had 2003. So when you remove those outliers, when you look at the median snowfall instead of the mean, our median snowfall is only about 10 or 11 inches now, which isn't a lot. This winter we're at 15 inches at Reagan National, and so we're doing better than the median. We're right around the mean this year. So we're having the kind of weather, snowy winter we should expect on average this year. It may seem like a lot because the last few winters we've had so little, but this is actually pretty much a normal winter in terms of snow in DC. But you can see the variability in that slide in terms of all the dots. Those all represent different years in our snowfall. And you can see we've had several spikes in recent years. Again, '96, 2003, and 2010, which was actually our snowiest winter on record. But you see a lot of dots below that black line, which is a trend, and that's unfortunately, if you're a snow lover, the direction things have been heading in, and that parallels that decline not the decline, but the increase in temperatures that we've seen. I mean, if our temperatures have been warming up 4 degrees for 100 years, that's going to mean that those marginal events, when we're right on the rain-snow line, the snow's not going to accumulate as well. Temperature's 33 and it's snowing, it's not going to stick. If you look back at March 6th, 2013, when we had the so-called snowquester event, where forecasts were for 6 to 10 inches of snow, and we got basically no accumulation in the city. Well, we were right on the rain-snow line when just a couple degrees made a difference. They got 6 inches out at Dulles, but we're in a climate where a couple degrees really can matter. And so when we are seeing these climate changes towards a warmer atmosphere, they do have impacts, and they do play out in terms of our day-to-day weather and what we're seeing. Just one more slide on our snowfall trend, another depressing graph, but in the late 1800s, we were averaging about 6 events of at least an inch a year. Now our average is about 3 events of at least an inch a year. So that's a pretty notable decline.
So enjoy your sledding while you can.
Yeah, pretty much. This winter we've had I think two or three events more than an inch. We've had several dusting events. So we've kind of seen this feast or famine type snowfall pattern. We're either getting a few big ones or not much at all. That's basically what our climate's been over the last 10 or 20 years. Now, whether it will remain that way, who knows? But I'm just looking at the data and trying to put it into a longer term context, and that's kind of what we're seeing. Next slide, and we'll get into this whole idea of the jet stream and its variability into the Q&A, but a hypothesis which has been put out over in just the last few years, which is that the jet stream is becoming more variable, and the reason that's happening is potentially because of the decline of ice in the Arctic. Basically, when you lose sea ice in the Arctic, you're warming that part of the world. You're reducing the temperature contrast between the high latitudes and the low latitudes, so that reduces that belt of strong winds at high altitudes, the jet stream. And when the intensity of the jet stream weakens, it starts to meander more and become more wavy. And when it becomes more wavy, that leads to more extreme weather patterns potentially. It might mean more extreme cold waves. It might mean heat waves lasting for longer periods of time. And so there's some anecdotal evidence that at least over the last 10 to 15 years, while we've seen this steep decline in Arctic sea ice, that the jet stream is starting to get stuck more, meandering more. And so rather than having more of a stable, stronger jet stream, which goes around the high latitudes, and more of a clean circle, it's tending to wander and meander a little bit more. So that's a hypothesis, and that might be behind the sort of more extreme feast or famine type weather pattern we've been seeing locally in the last 10 or 15 years. So with that, we'll take
and we're
questions.
seeing it in UK this year too. Of course, they and the phasing, the way the hemisphere works. Sometimes when we get severe weather here, or we're in
Right.
that pattern, the UK is also, and so they've
Right.
had quite a winter over there. Yep.
Is there going to be snow on Tuesday?
Is it going to be snow on Tuesday was the question.
I do your homework, as Bob would say. But, Monday night there may be a weak disturbance sliding by with a little bit of snow, maybe changing to a mix Tuesday morning. And I did take a look at the latest models before I came here, and it's not overly impressive. It's you'll probably get a little bit more snow north of the Mason-Dixon line, maybe an inch or so.
Might be a delay rather than a cancellation.
Yeah, maybe. We'll see. Stay tuned. Check the Capital Weather Gang. We'll be on top of it. So.
Those are the questions, of course. What is it? It's interesting as we're seeing our advance of the science is what do I do? What decisions do I make? Either from the short term for the picnic, or of course the politicians and the decision makers and people that want to be. What does it mean 50, 100 years from now for our grandchildren and children and great grandchildren? Okay, I guess.
Yeah, we had some questions submitted in advance, but if there are any right now, go ahead.
Can you talk about how the forecasts are getting more detailed and the technology around that, and how that's progressed?
Well, I think it's a combination of the advances in understanding a little bit more of the localized meteorology, the impacts of cities. A number of studies have shown, interestingly, as we sometimes observe, that the cities and what we thought of as being independent of the weather actually may have an influence on things like thunderstorms, lines of thunderstorms that come in and may be splitting the actually physical barrier. And also the particulates that are released in cities may have an effect downstream on some localized storms. So everything from very, very small scales that seem to be having an influence on some of the weather, to then the ability, obviously, to measure everything that you can get at home, like these meso networks that very accurately measure everything over a very fine scale. The ability to then have the new systems of radars that are actually measuring velocities, providing data, the more data. And Rick Anthes, who is a former head of one of the centers of research, and meteorology is sort of like a three-legged stool, including data, the computing power to really generate and solve the fundamental equations, because it is a science. And it's as much as a science of sending a man to the moon. The problem is it's more complicated to predict the weather than to send a man to the moon, but the same basic fundamentals of science apply, and then having a basic understanding of the science and the meteorology. So any one of those pieces of the three-legged stool is a little weaker and it wobbles a bit, but we're making, compared to 50 years ago in that first picture that I showed, we're making incredible progress in one, understanding, two, the observing networks and the data, and then being able to use that data in a useful way. Some of the first experiments took, the story goes, 5 days of computer time to generate a 24-hour forecast, which was an interesting experiment, but not particularly useful. And now the same thing can be done in a matter of minutes.
Yeah, I would just add to that there's a lot of cool work being done in crowdsourcing data. So apparently, so a lot of cell phones or handheld devices now have sensors on them which can measure barometric pressure or temperature, and there are also a lot. Apparently, Toyota is going to be putting into their cars, or already may have into their cars, and temperature sensors which will be able to be centralized into a database and then fed into models. And there are also commercial airlines which are taking measurements through various sensors. And the challenge is, you have this huge wealth of data, and you have these new ways of collecting information, doing the quality control to make sure that information is useful, and then integrating them into the model so that you can improve your forecast. I think that's sort of the next step that the community needs to take, because we are increasingly going to have new ways of obtaining weather information from so many different electronic sources, and so we've got to take that next step of making that data useful.
And that's why you hear this European model is better than the American model, and part of it is, one, they do have a little bit more computing power, but the whole way they assimilate their data is a little bit different, and also the task of the U.S. is much more broad-based than the task of the Europeans, trying to provide forecasts on a very localized basis, everything from severe storms to hurricane centers and to the national center. So they've got a challenge.
I hear you on TV talking about Doppler radar, and I've never understood what is that. Why is it different than other radar, and why does it make predictions better? It's a household term that I don't understand.
When you hear a fire engine or ambulance go by and the pitch changes, that's because of the velocity relative to you, and it's the same principle in the Doppler radar, and that it's a radar that's able to measure not only see what the precipitation is, but then using that Doppler principle, and it was a Austrian mathematician named Doppler of all people that explained the first thing, and so we use it to see the velocity and the movement of these rain, snow, and sleet, so we can measure then the velocity, which is really critical in severe storms.
Right, I was going to say during tornado outbreaks, you want to be able to understand which way you want to be able to see the rotation in a thunderstorm. So if you see this signal where the wind's blowing away from you and from one direction, but blowing towards you in another direction, that's an indication that you have rotation in the thunderstorm, which can be a key signal to issue a tornado warning.
And some of the new very high resolution actually now see debris. They could pick up the debris ball from the tornadoes that had gone up thousands of feet. So when they see that, that's a pretty good sign. Way in the back.
Yeah, you talked about increasing heat and how that may result in rain that would otherwise be snow. They made me wonder, what's the trend in terms of the total amount of precipitation per year?
It's interesting because we looked at that, and if you look at winter precipitation, it's flat. So we're basically seeing more rain, less snow. You're seeing, so the amount of precipitation, irrespective of whether you were measuring at 24th and M Street or whether you were measuring at Reagan National Airport, it's remarkably flat, the long-term precipitation trend here in DC during winter.
Yeah.
Is that true throughout the world?
Well, in theory, with the slow warming, there should be the feedback mechanism is one of the things that is of concern, because a warmer world, warmer oceans mean more water vapor getting into the atmosphere, and so that the real big challenge is sorting out the natural variability that we know is an integral part of our life and of the weather and of the climate, and what are the footprints and what are the signatures there. And things that, such as the decreasing glaciers, are some footprints, and the decreasing Arctic sea ice is pretty dramatic now.
And I would just add that there has been a modest increase in global precipitation over time, and so it depends from location to location. Some places are getting wetter, some places are getting drier. It just happens that here in DC our winters have been pretty much flat, but you're going to see changes. It depends, it's a chaotic system, but if you look at the globe overall, there has been a slight increase in precipitation, and that's likely due to the fact that the planet's been warming on average.
Yep.
on the chart that showed that the mean was shifting. You had the same bell curve, it just moved over. Is there anything else that's happening to the shape of the bell curve?
Sure, it could. I mean, that's sort of a simple conceptual model, probably oversimplified, but yeah, I mean, we'll have to see how it plays out, whether you're going to, theoretically, if the jet stream becomes more variable, you could have some areas, even while most of the world is warming on average, some areas due to just sort of certain atmospheric changes might become colder. Yeah, there are going to be regional differences, and whether that curve is going to be a exact bell curve moving forward, that's hard to say. I think I don't know if you have anything.
Or broadening.
Yeah, it's hard.
And I think the message from that is just doesn't mean that it's the probability of having, let's say, more 100-degree days in Washington is increased. Doesn't mean that every summer you're going to have now 30 100-degree days, but those are the difficult messages, the long-term trends, and sorting out what are the natural variabilities and what are the impacts that we're having. And unfortunately, thinking about the weather and the climate and the overall climate ocean system, it's got a long memory. It's a long lag time. It's like having a cement mixer coming down the hill, and now as it's gaining speed heading toward your house, you decide to put out a cone to stop it. It's not going to be too effective. So that's where the concern is that there's a huge built-in lag that is and that has some momentum, and we're not exactly sure where it's going to end up.
Right, and I think that gets to the sort of the question of risk management in terms of when we're adding all this extra greenhouse gas pollution into the atmosphere, you see these levels of CO2 which we haven't seen in hundreds of thousands of years, and you'll see some climate skeptics will say, oh well, the rate of warming has slowed over the last decade. There's this so-called hiatus or so-called pause, but for starters, that it's not really a pause. It's just the rate of warming has temporarily slowed, and as the Earth warms, the staircase doesn't necessarily just go straight up and up and up, so that each year is warmer than the next. You can hit sort of plateaus, and then you continue your rise. And so, basically, in terms of thinking about this as a risk management strategy, in terms of how we respond to the increasing greenhouse gases in the atmosphere, I don't think we should be careful about looking too closely about what's happening in a given year or a given place, but look at what the consequences could be of continuing to increase these concentrations, and the risk that the pace and the intensity of the warming will increase, and will have unwelcome consequences. So I think we really have to think about it in more of a long-term perspective, because the more we manipulate the system, the greater the risk is of unwelcome consequences, of surprises. And so even though the warming may not seem that severe over the last few years, at any point it could accelerate, or maybe it won't. Maybe the rate of warming will remain on the low side. But even so, there are other environmental benefits for reducing greenhouse gas pollution. So I think we need to be a little bit careful about looking at this from too short of a time perspective and from a more limited perspective.
And a lot of the weather events that, some people say, we've had more tornadoes. Well, then the number of people looking at that, on a population-adjusted basis, the frequency of tornadoes has not increased. The frequency of hurricanes has not increased. Right. So it doesn't mean that every weather event and every extreme that we see we can ascribe to we've done that. It's a complicated issue, and as is the decision making. If I'm a farmer in Saskatchewan and I'm told that in 30-40 years the average temperature in my growing season is going to be increasing by 30 days, I don't think that's a bad idea.
Right.
If I live in a small island in the middle of the Pacific and I've heard that the sea level is going to rise 1 foot, I'm a little bit more concerned. Or if I'm living in Bangladesh where the average sea level is
Right.
1 foot or so.
Yeah.
And cyclones, it's a
Right.
greater concern.
Yeah, so there will be winners and losers, but as climate change plays out, but I think in terms of managing the risks, if you want to reduce the probability of negative consequences, you have to address the problem by reducing emissions. Because if it's an uncontrolled experiment and you just keep putting this stuff up there, even if there are winners and losers, what's going to happen is if the rate of change gets too high, it's going to challenge our ability to adapt. And so that's really at the thrust of this issue, is can we adapt to the changes that are happening? And the more we put into the atmosphere and the faster it happens, the less likely we're going to be able to keep up with the changes and respond appropriately. And so I think that's why you have to think about this as a risk management problem. It's not because we can't necessarily in the mid-Atlantic deal with a degree of warming every 50 years, but it's thinking about some of these more vulnerable locations that could.
I think a good analogy is when new drugs or experimental drugs come into being, and you run an experiments, and you have a placebo versus the group that you're giving the new drugs to. Unfortunately, we don't have a placebo for the Earth.
Right.
We're running an experiment with only one case.
So if hurricanes and tornadoes are flat, is the severity of hurricanes and tornadoes increasing, or is it just
tornado?
perception?
First of all, our tornado data isn't very good. We don't have. I mean, the U.S. has the best tornado data out there, and
Because we have more tornadoes.
because we have the most tornadoes. Yeah, that's right. But we don't have a great long-term observing record because in the 60s and 70s, not every tornado was, you didn't have all these storm chasers out there, you didn't have a Doppler radar network, so our monitoring of tornadoes wasn't great. So it's hard to say. I mean, we can estimate how many tornadoes there were back to about 1950, but the people who've looked at this haven't seen a notable shift in terms of the severity.
Damage-based population control seems to be steady. The insurance, it's sort of an adjusted insurance, and I think similarly to hurricanes.
Yeah, I think with hurricanes, I think in the Atlantic since the 1970s we have seen an increase in frequency and intensity, but that might be tied to this what we call multi-decadal oscillation, and where for 20 or the hurricane activity goes through a 20 or 30 year cycle where you have an active period and then an inactive period. So we're since the 90s at least we've been in an active period, and so that's why you might see somewhat of an increase in the intensity in the Atlantic since the 70s. Globally, if you look at global trends, it's really difficult. Some basins have seen increases, other basins haven't. I think there's some evidence which shows that the intensity of the strongest hurricanes, the Category 4s and the Category 5s, there has been somewhat of an uptick in those, but it's still the signal is still pretty weak. I think the computer models all project moving forward that in all things being equal, the intensity of hurricanes should get stronger just because you're putting more, you're warming the sea surface temperatures, which basically serve as a fuel for hurricanes. But whether they'll become more or less frequent, that's more of a challenging issue because there are other competing influences in the atmosphere which might reduce their frequency and increase in wind shear, for example. So these are all really challenging issues which climate scientists are studying. But as of now, I think the identifying either a strong signal in tornado or hurricane activities.
And it's very complicated because, of course, so many more people now are living in hurricane-prone areas, and it gets back to politics. You've got a building permit in a flood-prone area, and on Staten Island, should have those people been, the politicians say, and the developers come in, we only have a flood once every 100 years, we can build here. And those decisions have repercussions. Some people think in a few years, but it turned out it was only 2 or 3 years. And
well, we are seeing more billion-dollar weather disasters, but that's probably just because there's more people in harm's way and there's more infrastructure. So.
as professionals in the field, do you feel the theories of climate science are more generally accepted? And I don't mean that as a political question so much, though you're welcome to talk about it however you want. But we certainly went through a very long period where it was just debunked. Where do you think we are in the perceptions of it as a general public and perhaps world governments? I'd be very interested in your opinion about that.
I'll take a crack. So, in terms of
I'll
public,
add to it.
yeah, sure. I think in terms of public attitudes, I think some of the polling data shows that most Americans do believe global warming is happening and that humans play a role in it. I think the public thinks that there's more disagreement in the scientific community about the issue than there really is, because there's actually a pretty strong consensus in the scientific community that climate change is occurring, that is the Earth is warming, and that humans have a lot to do with it. So I think, yeah, I think the public's mostly on board with the issue, but you certainly have a contingent of people who remain skeptical, who aren't convinced that human influences are driving the trends that we're seeing. I think the data maybe shows that's maybe around a third or so of the U.S. public, and if you look at the demographics, it tends to be white men who are most skeptical. And Republicans. So that's just what the data shows. I'm not trying to make any sort of judgment on that. So, but that's kind of where we are. But I think there have been studies which have done analyses of the scientific publications on climate change, and they found that 97% of studies in the peer-reviewed literature support the general notion that climate change is happening and that humans are playing a significant role in it. So I think that's kind of where we are right now. Obviously, I think on some of the in some of the op-ed pages of newspapers and on TV, you're seeing you often see it as a two-sided debate, whereas it really isn't that in the scientific community. And there are legitimate scientific skeptics out there, and I don't think we should be demonizing people with alternative viewpoints. There's a lot of name calling, unfortunately, on this issue, and there's a lot of I think negative energy which plays out in the blogosphere and in some of the talk shows. But so I think debate and discussion amongst people who have alternative perspectives is good as long as it's respectful and productive. And there are people like Judy Curry at Georgia Tech. She's the head of the atmospheric science department there, and she's not convinced that some of the mainstream conclusions on climate change have been as well vetted as they should be. So there are a range of views out there, but I think where most of the scientific community is how I just summarized it.
Yeah, and I today was interesting on Meet the Press, so-called debate with Bill Nye and then a conservative congresswoman from Kentucky, and she cited Judith Curry and Richard Linston, who are and the word skeptic even. Every scientist is a skeptic. It's one of those words that's sort of been grouped. If you don't accept or believe that we should all turn off our gasoline engines and go back to burning by candle or firewood or something, that you're tree huggers and all of the and as Jason says, it's gotten unfortunately name calling, and because it's now become a decision-based political process, then the science sort of feels like it's become these two camps, and it's really not two camps. It's several prominent people who are still practicing scientists, and a number of scientists who have absolutely no background in meteorology or climatology, but I've written up blogs, and they have more of their own agenda for economic, philosophical, even religious reasons, and then look upon the science as a way of rationalizing and saying, well, this is the direction things should be going. So the overwhelming number of climate scientists who are really working in the field, it's been 90% believe that the human footprint is there. So it's like 3,000. I sent a quick tweet. It's 3,000 to 3. And if that were the score, you would say that's a blowout. Right. But unfortunately, if 2 or 3 also are raising. And then the analogy with the decisions that were made on smoking and tobacco. Obviously, there was a very, very strong effort by industry and economic interests to deny that there was a linkage with public health, and now it's generally accepted. And decisions were made by the government many years ago, even though it was not 100% linkage, that we should be doing something when it was the studies showed that there was a 60 or 70% probability of a linkage. And that's where we're approaching the understanding and the linkage with the climate weather issues. And so political decisions can be made without 100% certainty.
Yeah, thank you.
Sure.
Get on to something completely different. There's so many terms that come up in meteorology we hear on the weather, and I'm thinking of two that I had to experience personally myself outdoors. A microburst and a derecho. Could you kind of give the difference between where they what spawns them, what triggers them, what's actually happening?
Yeah, Jason did a great blog on derecho.
I'll do derecho. You can do microburst. So derecho, it's basically it derives from Spanish, which means straight ahead. So it's a fast-moving, very fast-moving complex of thunderstorms, which forms along a straight line. It's a long squall line, and I think it has specific criteria. So it has to have, I think it has to be 250 miles long. I think it has to be moving at about, it's either 45 or 60 miles per hour. It has to be moving fast, and it also has to have damaging winds along the entire storm complex. So that's basically the criteria for derecho. Again, fast moving, expansive, with damaging winds along the entire path. And it forms when you have basically a lot of heat energy in the atmosphere, and you need a trigger, so you need some sort of little wave in the atmosphere or disturbance coming through to help it fire up. And then you also need some cold air coming in at high altitudes to help destabilize the atmosphere. So, and that's what happened back in June 2012, June 29th, 2012 here in the DC area. You had a little short wave, small scale wave in the atmosphere moving through the upper Midwest. It was moving along the jet stream near the Iowa, Illinois border. You had a complex of thunderstorms develop. That day happened to be the hottest June day on record here in the DC area. It hit 104. It was hot across the entire eastern 2/3 of the nation, but you had this boundary to the north separating that hot air from cool air. And so the derecho basically traveled along that jet stream, but then the line of thunderstorms expanded to the south as some of those cooler upper level winds blew in behind it, and we had over 1 million power outages here in the DC area as a result. It was thousands of trees down and 70-mile-per-hour wind gusts throughout the entire region.
Yeah.
And the microbursts are an example of the great advance in meteorology through the instrumentation and things like the Doppler Radar. And it's basically in very large thunderstorms with hail and rain that's up at levels where the temperature may be way below zero, as cold as -40. And then that cold air generated begins to accelerate, and because it's moving into a warmer environment, actually will accelerate up to 60 to 70 miles an hour, and then it hits the ground and has no place else to go and spreads out and actually can, and you've probably felt it with a rain shower. Well, these microbursts were responsible for a number of fatal airplane crashes, Kenner, Louisiana, and then there was a crash in JFK, 1960s.
Yeah, 69 maybe.
But then through various studies, now we were able to detect those again through things like the terminal Doppler, which have been installed on all the airports. So there have been a number now of pilot training that know that when they're flying into a certain circumstance, they're either diverted or how to react if they happen to get caught into a downburst. So, the science, the combination of the science, the technology, and the observations, that now is no longer a threat, but it still is a real phenomenon.
On the subject of forecasting, every TV station has got, radar, and it's got a bunch of folks, radio stations, Washington Post. But are they getting most of their information from NOAA, and are they just evaluating it individually, or are some of these stations actually getting their own raw data themselves? And I guess the other question related to that is everybody that's standing in front of the TV camera a meteorologist, or some of these folks just reading a script that they're getting from somebody in the back room?
I'm retired, so I can tell you.
Get the inside scoop.
Historically, there have been a number of people that were broadcasters, and I would say across the country now, with a variety of continuing education and their variety of programs, most of the people you see have some background in meteorology. Are they degreed meteorologists? No. But some are excellent communicators and some are pretty good forecasters. So I would say across the country, probably now more 60 to 70% are meteorologists, and yet many are also excellent communicators, know their local area. The basic structure that we all depend upon is indeed the Weather Service and NOAA, and the basic models and the simulations that we. But each one of those, the one great advantage I think in any area of television is one, being able to effectively communicate what you feel is the best forecast. And there are a number now. I can go to different university centers, see experimental forecasts, very small scale things in our area. There are years ago we set up networks of weather watchers to be able to see things on a small scale, but and it's a matter of interpretation, experience, and then effectively communicating. I've said in, as Jason has done, he puts in confidence. How confident are you in the useful piece of information for making a decision? The whole process starts with the observations, then the machines that generate the information that we use, the forecast that we then communicate, but the ultimate line is the decision. I can make the most accurate forecast and be very proud of myself, and then run into somebody and said, I didn't understand what you said, or I made the wrong decision, or I drove out, and then I failed in my job. So it's a combination but the basic heart and soul, let's say the skeleton of the forecast body is your tax dollars. Thank you very much.
And there are some television stations which have their own Doppler radars.
Yeah, their own Doppler, and
right,
they
you
do run.
You had a Channel 7. You had one out
yes,
off Route
right.
50 there.
Yeah.
But fundamentally, most TV stations are relying also, even if they have their own, they're relying on Weather Service radar as well, because the Weather Service radars tend to be more powerful and cover more of the area. But yeah, I mean, I think Bob has it right. I would say in most major TV markets where weather is significant, maybe not in Southern California, but most TV stations have meteorologists on staff. Maybe not every one of their TV weathercasters is a meteorologist, but as Bob said, they're distance learning programs where they can take courses and get up to speed relatively quickly. Yeah, so I think.
In certain markets, when I was in Boston, they're weather-sensitive markets. Oklahoma City, you better know what you're talking about.
Yeah, you got it.
And some of the stations now we can, because of the computer power, there are some very small-scale models, and that's why you see some of these that are simulations. And they're, I often think, what do the models say? And I think it's like, what's Heidi Klum have to say about tomorrow's forecast? But it's really a simulation of the weather. This idea of computer models. So I'm still cranky enough that some of the things that I hear get me. Another favorite is piece of energy.
Right.
I have a imaginary of a half of an ever-ready battery up at about 5,000 feet flying along. So we have to, we obviously communication is still vitally important.
Are we simply more informed, or are things getting worse? And the analogy I would draw is when I was a kid, when it came to the news, in the evening, and we saw a half hour of CBS Evening News with Walter Cronkite. And that's all we knew. So we didn't really know what was going on in the world. So the analogy, the comparison I'm drawing is 24 hours a day, 365 days a year, we've got weather, we've got world turmoil, we've got everything going on, people can't get away from the news. Do we simply have more information, or are things really getting worse with the weather?
I think it's more. I think it's more information. Actually, that's what I would say. I mean, because you're absolutely right. I mean, you can get inundated with natural disaster or weather information if you want to. If you're a consumer of that information, there are so many sources.
And then New Jersey was an example.
Well, that's right. Yeah, I mean, you've got social media, you've got Twitter and Facebook. So you've got high school kids who are putting out. They're seeing these long range models which have little credibility because, frankly, our ability to predict doesn't get very good until within about 3 or 5 days. But there are these models which are out there, which extend 7 to 10 days in the future, or if not longer. And anybody can get their hands on them, and they can see, oh wow, this computer model shows 20 to 30 inches of snow 10 days from now, and they put it up on their Facebook page, and it goes viral. And so and that very thing happened last week, and it misled a lot of people. It got into the hands of emergency managers who didn't know better. Not everybody understands what the limits of weather predictability are, and so there are so many sources of information. So I think that comes back to the importance of trusted sources and knowing who's credible and who's not. But yeah, I mean, in addition to social media, you have and TV, you also have new websites which are getting into the weather reporting game, like Mashable, BuzzFeed, Gawker, Slate. So there are a lot of media entities which are understanding and appreciating that the public has this tremendous appetite for weather information. People really are interested in this subject, so there are more and more opportunities and more sources for getting weather information. So,
and not to mention the Weather Channel that wants to sell you lots of products.
Well,
yeah.
That's what pays for that. Yeah, and it's interesting to see how far we have come. I mean, the private sector is a huge part of the weather business, if you will, and the economic benefit of accurate forecasts from shipping to trucking to everything, the utilities, is in the billions and billions of dollars. So the open exchange of information is vital to that. And yet back in before this weather industry and this weather enterprise expanded so much, back in the 50s, the first person to talk about a tornado on television was Harry Volkman in Oklahoma. And he, because of the concern of public panic, the Weather Service didn't even want to mention a tornado. And he was almost arrested for going on television at his local station and mentioning that there could be, the atmosphere looked that it could be a tornado, and the authorities and it was very, very strictly controlled, the information. So we've come quite a ways from arresting somebody to talk about tornado warnings to having this wide range, which does create a lot of misinformation, but it's challenging, I think, for the average user to make a decision.
Right, and there's also this desire to be first. So you have no, I mean it's sort of like everyone's going after it, and people are trying to hype it as much as they can, and in order to get the recognition and the credit. So you have to be careful about that, and so there are going to be more and more ways of getting this information. So I think it comes back to knowing, who the trusted sources are, and also who's there all the time. You might have some fly-by-night operations that one day are putting out a forecast, they're gone a few days later. So
not the Capital Weather guys.
We're always there. always on. So
well, we have to wrap it up here. Unfortunately, we're at time. But the last set of questions reminded me of one of the questions that was submitted in advance, and that is, I'm going to try and paraphrase here, but have you ever met anybody who intentionally tried to sort of stay away from all these sources of information and wanted to prefer to experience the weather sort of on a primary experience basis? That was one thing. Can you flip to the question, Ron? Because I don't want to, it's a little bit of a longer question. Yeah, that's the one. Have you ever met someone who avoids listening to or reading about weather forecasts, instead preferring to have a primary experience of the land, nature, and weather? Have you ever heard of this?
They're called a farmer.
Farmer!
And, it's interesting that they are in it each and every day. And indeed, you know, the earliest forecasts were made by analogy before we had all of these things, you know, red sky at night, cellular delight. And the people that are out there and that have to make the decisions and still rely a lot on the way they observe things and observe nature. And you know, it's again a personal decision-based process. And perhaps sorting out and getting away from some of the noise and know that there was a story in the Post, a fellow has to get up at 3 or 4 o'clock in the morning because it's calving season, and he was out there, and was it 5 inches of snow or 4 inches of snow? He didn't particularly care. He had to get out there and do his job.
Anyway, yeah. All right, great. Well, thank you guys both so much, and thank you all for coming today.
Keep reading the Capital Weather Guide.